All right, folks, you're here for the TLS meeting, then you're in the right place. We're going to get started now. Do we already have a scribe? All right, I need a note taker. Oh, that's true. But just in case the cloud does not do exactly what we want it to do, can we have somebody volunteer for notes?
Anybody? We don't need a minute, like word for word.
Yeah, this is just recording the major actions so that we can test it against the AI later.
I did it for HTTP this.
All right, thank you, Chris. All right, folks, here is the note well. What? Yeah, you've already agreed to all this, but just a reminder that these are the policies about conduct, privacy, and intellectual property that you agreed to follow. So if you have any questions, you can talk to the chairs of the ADs. All right. Please join the meeting with your on-site tool so that you can join the queue. That's how we'll manage the microphone line, both for online attendees and on-site attendees. Don't turn your video and audio on for remote attendees until you are talking and presenting. Okay, we have some things on the agenda. Yeah. All right, just some things to note. We have a couple of adoption calls going on and a working group last call going on right now. So.
No, I'm just getting the QR code.
Okay, I thought I was in trouble again. Yeah, sorry. And so for today, we have DTLS and then some non-working group IDs. Any other business people would like to discuss?
We might have an additional one if we run out of time.
If we have enough time, then there will be an additional surprise presentation, I guess. All right. So shall we get started with I don't have the clicker here.
Thanks. So this is my homework from last night, literally. Next slide. Oh, I can do next slide, can I? Ha, look at that. Maybe. Okay. So I guess as backstory for people who may remember, we had 8446 and we are doing 8446 BIS to clean things up. And I hopefully thought 9147 was really done, and then David Benjamin read it and then it wasn't done.
Can you slow down?
Yeah. So we're doing 9147 BIS to clean up a bunch of I think somewhat more serious issues, but not too serious, hopefully, in 9147, largely in response to some comments from the Chrome team. Hannes did yeoman's work and generated a lot of PRs based on the existing errata, which have already been approved. The 01 draft includes basically a pile of these errata. I'm not going to go through this in detail. You can go read them yourself. I think they're all essentially uncontroversial. They reflect real defects in the specification of various kinds. I want to talk through a small number of issues, but not all of them, largely because I didn't get to all of them. I don't know what to tell you, man. Like pressing the button. I think we're going to have to because I'm pressing this pretty aggressively. Okay. So as I'm going to go through a selection of the issues. This will not be all of them, but hopefully some of the major ones. The first issue, RC 9147, as all previous versions of GTLS, has a replay detection and suppression mechanism inspired by the old IPsec sliding window mechanism. It's always been optional. Namely, you could detect and suppress, or you could not. John Mattson pointed out that it would be better to have it mandatory, and in particular that there is at least one setting where with post-handshake authentication, where it's a little unclear what things look like if it's not mandatory. Like if you're doing post-handshake authentication and you don't suppress replace, then what are the semantics of that? It's may or may not be okay, but arguably easier to say like, why are we allowing replace at all? We could just ban it entirely. Paul, do you want to be in the queue there? Okay, great. We could just ban it entirely, but the problem is it turns out that and we had a long discussion with Michael Tucson on the issue that DTL service CTP has its own replay detection, that should say, so it doesn't want duplicated drops, and in particular, Michael's point is there's like the way that the window mechanism works is like a sliding window, and that you might have the things that are the SCTP is maintaining it like a longer window, and so you drop things in the DTLS layer, but after the SCTP layer, that's obviously bad. You don't want them fighting each other. So I think there are two options. One is to leave it as is, in which case we'll have to re-examine this question of the post-handshake authentication and make sure it's okay, which I think it probably is. And the second is to basically write some text like I have here for option 2, which is to say you've got to do it all the time, except unless you know your transport has anti-replay, which I think like the only case that really is this SCTP case. Paul.
Paul Wouters, IPsec enthusiast and not speaking as AD. We're just designing a new version of ESP in IPsec working group where you can disable replay detection because it really sucks for performance.
I see.
So I would strongly not recommend making this mandatory.
That's really helpful. I did not know that. I don't have a strong opinion on this. If other people do, you get the mic now. Otherwise, what I'll probably do is go read the spec and see if I understand John's point about the post-handshake authentication and see if it's right and if he has to deal with it, and propose something that way. And John, of course, on the list. I don't see John in the queue or anything. Can complain that we did this wrong, and we can take it to the list as well. Okay. Next. Okay. This is a fun one. So RFC 9147 specifies how to use ACKs in every epoch, including epoch 0. It also includes epoch 1, which is incoherent, and we removed that at Benjamin's suggestion. Epoch 1 being early data. But the problem is you're not allowed to send ACKs to DTLS 1.2 clients or DTLS 1.2 servers for that matter, because it's an illegal content type and they will choke. And so this mechanically can't do it. But that means you can't send an ACK until you know the version is DTLS 1.3, otherwise you're going to cause errors. Does not mean that it's not impossible to know when you can send ACKs, but most implementations parse the client hello or the server hello in one big chunk, which means there's just basically not a very common situation, at least in a one round trip handshake, where you would know that the other side was DTLS 1.3, but you would not have like the entire client hello or server hello to work with. It's not impossible, you'd know. So say, for instance, that like the supported versions was like the first extension and it like made it the first packet, and like you had a giant post-quantum and so upstream with all packets, but it's not like a common setting. The one case when it actually is kind of plausible that you might know you had 1.3, but also be able to use ACKs is after HRR, because after you've received an HRR, then you do know you're in 1.3 mode. David's comments on linked out of issue 291, he suggests that it's probably easiest to just ban ACKs entirely at epoch 0. This will definitely not cause a, well, let's not say definitely, but should not cause a functional regression, because you don't need ACKs to make the handshake complete, because you just retransmit the whole flight. It may cause, if the client hello was like super big, like you're doing classic pick lease, what might happen is we get a less efficient first flight because like you have to retransmit the entire thing rather than just the pieces that were delivered. I think this is probably a pretty low impact change, because like we almost never do have like things spanning like a big ton of packets at the first flight, And if we probably did, and like if we did have class of McAleese, we'd probably find some other thing to do. So my instinct is that this is like a lot simpler to do what David's suggesting, if we remove them. What we'd actually formally have to do is to forbid sending them. And then, but if you receive them, you like ignore, you can either process it or ignore it, because there might be 9147 compliant clients or servers who already sent them in some confused way. And so you don't want to create an route problem. So I don't think it's a problem to fix this, but I think so. If anybody wants to speak up, from me, Martin, in favor of retaining accident bug 0, now is your time.
So Martin Thompson, this is not very loud. So I'm a little interested in the assertion that you can't send an ACK to a DTLS 1.2 client. This is DTLS, right? And so if you get garbage, you're supposed to throw it away. Does that, are there situations in which the acknowledgement would cause the handshake to fail? Because it will be marked as a different record type. So it's not going to come through in a way that would look like a handshake.
You know, I have to admit, this is not something that occurred to me last night at 10 p.m. I don't know if, I don't in fact know what implementations do if they receive unknown record types.
Yeah, so I think that may be the question you want to have answered here, because if they are just discarded as they should be, then keeping the ACKs is useful because it means that you get better loss recovery for that first round trip.
Assuming that there is a scenario where you're aware that
it doesn't matter.
Yeah,
you would just always acknowledge.
You're saying if you're a 1.3 stack and someone sends you a client who will have any flavor, you send ACKs.
Just send an ACK. Yeah.
So I think that we really want to persuade ourselves that like there was no stack that freaked out in the circumstances.
Absolutely. That's why I suggested.
And there's also, by the way, a separate PR or at least a commentary from you about clarifying what it means to reject bad packets. That I think I tagged you to ask you maybe if you could produce some text for. So that may interlock with this discussion.
Great. Yep.
Paul Wouters, again, IPsec enthusiast and not AD. I'm just triggering on you get full retransmit there in the classic McAleese case that you have there. Again, in IETF, we can do McAleese by using IETF fragmentation, and a protocol there has like, if you miss a fragment, you ask for a retransmit and you get all the fragments again. And it's like, well, it's not really optimized, but it will work. I'm not sure if this is doing something similar, but we've now found out that in some practice deployment cases where people have actually done this in production, that you run into cases where you actually never complete a handshake because you'll never actually get all the fragments collected.
Yeah, so the way DTLS is supposed to work is that, well, the way 1.2 worked is there were no ACKs at all, and so you retransmit the entire flight. And so in this case, what would happen is you time out and you retransmit the entire flight. And so what the ACKs were designed to do is allow you to suppress some of the unnecessary packets precisely so you made headway in the way you're talking about. But it should, I mean, if you are like running this situation where like the reason you're getting drops is because you're like overrunning like some very short queue, and so you always lose the last 2 packets, then yeah, it will never complete. But other than that, if it's just like random drops, it should work fine.
David Benjamin, I will double check this again, but when this came up, I'm fairly sure the reason this came up is that all OpenSSL and all OpenSSL derived stacks will get upset if you send an unexpected content type. The like allowing error thing usually is limited to, or in the stacks that I'm familiar with, it's limited to decryption failures. And since we haven't started decrypting in the first place, like there are no decryption failures, or decryption failure and failure to parse the header. But
Right.
we are succeeding parsing the header. Is just that it is garbage.
Could you check for us?
Yeah, I'll double check for sure.
Yeah,
I'm fairly sure that
I mean, I guess my put here is if David is correct, then we kind of have to just like live with this problem and turn it off. And if David is incorrect, then we have to do some more research to find out if Martin is right. Does that match your opinion, Martin? Okay. So I think we have a provisional way forward of some kind. I don't think we have to wait for David. David, you could do this later. Next. Okay. We had, so as people may remember, 1.3 now encrypts the sequence numbers, imitating Quick. NVIDIA proposed an extension a while back for unencrypted sequence numbers. Hannes made an issue, so I'm dealing with it. I do not think we should adopt this in the core at all. Like if they wanted to publish as a separate extension spec, maybe that's okay, but like I don't think any change to the core is indicated, so I want to just close this issue with no change. Okay, I see some thumbs up, so we're going to do that unless somebody objects.
David,
Deirdre.
did you want, no, you're out. Didn't SSH just have a bug that they are deciding to close because they had unencrypted numbers, like this control flow numbers? So I think we should not do this.
I think we're okay. So from the perspective of this presentation, we'll just turn this off, and then if they want to come back with this, we can debate that later without having to resolve the question you just raised, which I am horrified to think about. Next slide. Okay, so where are we? I think we have ways forward on the issue that I just raised. There are a few more issues that are floating around. David had raised some issues around acts around epoch boundaries, which are related to this epoch zero thing, but not exactly the same. I need to frankly go through those and make sure I understand it. So I'll come back to the working group with like an attempt to like channel David some, and probably after I've talked to David, produce something that makes some sense. I imagine what those will say was like whatever David wrote in the erratum was what we're going to do, but I won't be sure until I've read them. There's a few outstanding small issues I got questions on. I'm hoping to like resolve all this stuff by like basically the next IETF. David and I chatted a little bit earlier, and he pointed out that like the writing in this is not necessarily as clear as it could be. I don't think either he or I or Hannes really have the energy to like go fix that stuff up. So my target here is let's improve the situation. David found a bunch of problems. Let's fix the problems so that the spec becomes clear on its own face. And then if someone gets the energy to do a bunch of the writing cleanup, we can do that later. But like, I don't want to hold that up because I think that practically the chance I'm going to be able to do that is quite low. If there are any, so please consider this to be a not last call, but a call for if you are aware of any more technical issues in the spec that are not reflected either in the spec in the current draft or in the issues list, please tell me and put them on the list because I'm planning to work off that list. And when that list goes to zero, which I'm hoping is by the next IETF, then I'm going to ask the chairs for working at last call.
So the only other thing I can think of is that there are like 9 or 10 errata against DTLS 1.2 that it would be nice to see if we've addressed them as well. I know Hannes had a bunch of errata, but
Those were against 1.3. I can go look.
Okay, that's awesome. Thanks.
Okay, if you could file an issue so I don't forget that, you can just like literally say do the errata from 1.2 and I'll know what it is. All right, people are getting a lot of time back. Is it Nick?
No, it's Steven. Sorry, apologies.
Hey.
Sorry if I do it for you.
Yeah.
Well, let's see.
No, you can do it.
There you go. All right, that's back.
All right.
Yeah, it works.
It's fixed. Okay. All right. So this is a draft. Way back when I kind of proposed that maybe the working group would think about adopting it. It just specifies a file format for ECH for private key and an ECH config. And that's an example. And that's about the limit of the spec. There's not much to it. Meanwhile, it's been implemented. So it's part of this OpenSSL ECH feature branch. Boring, doesn't produce these things or consume them, but there's a small shell script you can use to do it. And then a bunch of servers are in various stages of incorporating this format as a way to store ECH keys. And you can see the status there. A bunch of them have code. It's not necessarily released. Pardon? Back one slide. There you go. Okay. And forward one slide. So if we wanted to make changes to it, later would be a really bad time. Now is not a great time because you'd have to go, beg all these people to make changes, but it's very simple. So I don't know if there is one. Anyway, so a while back on the list, I said you should be looking at this again because now is a good time to make changes if they're really needed. But meanwhile, some people said, well, it's a private key format. We might want to do it. Paul agreed basically on the basis of the precedent of RFC 7468, which I can't remember what it is. Some other file. PEM file for some. Anyway, so Paul said, hey, he's okay to AD sponsor it. Seems like a good plan to me. If people want to read it, and it's very short, then it'd be great to get comments. Like I say, changing anything, there's not much to change anyway, but changing it significantly might be a bit of a pain because you'd have to go back to all those maintainers and ask them to change code, but editorials and stuff would be fine. So, and it would be much harder to change later. So if you do have comments, now's a good time. So this is no longer asking the working group to do anything other than not complain to Paul. Or complain now if you want to. So. And I think that's all. Anybody want to complain? Not complain?
I don't want to complain. I'll offer to shepherd it.
Thank you. Yaroslav.
Yeah, I want to complain a little bit. I know that it's too late,
Mike,
but right. I want to complain just a little bit. I know that it's probably too late, but having ECH config list that contains always one config is a bit weird. I think it would be better to just have ECH config.
So it no longer says that. It says one ECH config list. But it can be multiple ECH configs in it as long as one of them matches the private key.
Oh, so can you have multiple private keys of different formats and ECH?
One private, 0 or 1 private keys only.
So there is no, you cannot have multiple different ECH configs with different cryptographic.
Yeah, you could have multiple ECH configs if they match the private key. You could change the AEAD stuff or the public name.
Okay. Would it be feasible to have multiple private keys if you could have multiple ECH configs so that you could?
I think that would complicate it undesirably.
But it won't break existing implementations.
It would. It probably would. And it's undesirable anyway.
Okay, thank you.
But yeah, I mean, I guess there'll be a last call. So, Osama.
Yeah, somewhat you Dresden. So I just wanted to be sure there was an extensive formal analysis. There was an extensive formal analysis, and I was wondering if this change was already, or this configuration that you propose in this specific draft, was it already verified, or does it even need any analysis at all? Or
It does not. It does not.
okay,
have
I
a
haven't read the
cryptographic
draft.
change.
Okay,
No,
sounds
it's
good.
just a file format.
No need for a crypto.
It's not making a change to TLS 1.3 key exchange protocol, anything like that. It's just a file format.
Yeah, it's mostly harmless.
Yeah. So apologies, Stephen. I haven't read this draft. That's why I asked you to go back. So is are these separable? Namely, can you have the ECH config without the private key?
As with current, I've oscillated a bit, but yes, you can have 0 private keys.
But that would be not nothing between the tags, but it would be nothing that said begin private key.
Yeah.
Okay.
Just ECH.
Okay. Yeah. Okay. For what it's worth, I think it is a little unfortunate. You can have more than one public key and only one private key, but I guess I understand how you got there. Okay. And the private key is the same format as it always is. That is the same format as like every other private key.
As far as I know, it is, and if it's not, it should be.
It seems harmless.
Yeah. Okay, harmless. Great.
Thank you.
Thanks.
All right, Nick, you are up next. Find the slide. Nick or Dennis, I'm not sure. All right, you do a clicker. You do it. You apparently have control. Or will, so there we go.
Okay, hello everybody. We're going to talk about ECH again. So it's been deployed in a lot of different situations. We talked about it at the last IETF meeting and the meeting before. This challenge with respect to updating the ECH configuration if it's out of date. There's a mechanism for doing so, and it's deployed and it works. But the issue is that it's restrictive in terms of how ECH can be configured by clients. So here's the main issues that we're hoping to deal with in this new draft is that these ECH configurations are basically a structure containing data that is unsigned. It's served by DNS or via HTTPS, but itself does not have some way to authenticate it as an independent object. So this indicates that there's potentially a need for a single authenticated update mechanism if you have an ECH config that's out of date. So this is the proposal. I've discussed with this extensively with Dennis and Alessandro, who are going to join me on this draft. But the idea is that there's an extension for ECH config that advertises public key hashes or certificate info that correspond to ways to update this particular object. And so this would be delivered either in DNS where the ECH config usually is, or in the TLS encrypted extensions in the retry config, which is the current mechanism for getting an update. So we have in this draft defined 2 authentication modes, and we might want to end up with just one at the end of it, but these 2 seemed to have distinct benefits. The first is a raw public key mode, where when you first get your ECH config, it has a list of hashes of keys that can be used to sign any config that can be used to replace it. So this allows in the TLS handshake the retry message to be signed by one of the keys that was originally in the config, and you can check that and validate it without having to go through the current mechanism, which is relying on the handshake certificate to authenticate this object. The second mode here is certificate-based. This is much more closely aligned with how the current mechanism is for updating ECH configs, but effectively, you sign the ECH config with a certificate that has a new critical extension for ECH config signing. So it can't be used in other situations. But it's just as you have to validate this public name in the TLS handshake. In this case, you validate the public name in the certificate that's sent along with the object. So this is what it looks like. It's a new extension in the ECH config. It has auth method, auth info. This includes something that I'm sure people will discuss, a mechanism for expiration for these keys. But it's relatively simple, either a list of hashes or a certificate chain and not after. So here's it's very, very, very simple, and the signature's at the end. And so this is required to be the last extension so that it signs the entire object. Next one. Okay, so why do this? This seems like it's working. Why are we even updating this? But the idea here is there's advantages like deployment agility, which means you can do this ECH key rotation through all sorts of different methods, not just DNS. We also have the HTTP distribution method. This helps bind the authentication to the object itself so that it's cleanly separated. Another thing that this allows, and this is sort of secondary, but was part of the genesis of this idea, is that it does enable something that's allowed in the ECH spec, which is for the client to choose different names in the outer SNI, and for the name in the outer SNI to not be related to the authentication of the update. So this is a good thing. It allows more flexibility on clients with regard to using this deprecated outer SNI field that's currently being used to in current deployments to list the public name. The other benefits here is, it's a unified framework that doesn't require cross like object to protocol validation of trust. It's all self-contained. It's relatively simple. The state is for the certificates is you really just have to have a certificate, and with the keys, a mechanism for having keys and updating them and publishing the hashes in an ECH config. The other good thing about this is that it fits into the ECH retry config mechanism very nicely in TLS. There's no changes to TLS required for this. All right, so why are we here? What am I asking for? well, we'd like folks to try to implement this and interoperate and to see which one of these two modes is easier or is preferred for folks who might want to implement this, both on the client side and on the server side. We have open questions here about operational guidance, what the expiration window is, retry policies, whether or not you can put signed things in. There's just some questions about where these things go that we'd like to discuss. And yeah, speaking of implementation, if folks want to implement it and give feedback to refine the mechanism, speed up deployment, we'd love for that as well. And so with that, we can do questions, if there are any.
Usually ECH brings everybody to
Hey, there they are.
No, I was just going to be supportive. Yeah, I think we should work on something like this. I mean, I noticed you're not asking for adoption yet, and I think that's probably correct. I think some of the ideas might need to be fleshed out a bit more before you get there. But I think working on this seems like a sensible thing.
Okay, we now have people to ask questions. Yes,
Yeah,
Martin.
That's great. Martin Thompson, I'm enthusiastic about working in this general area. I think it's probably something that would make the recovery path a little bit more robust, and potentially some privacy stories could be improved. I do think that there's some interesting questions that deployments will have to ask if they hand clients the ability to choose what the public name is. That has implications. I do think that you want to choose one. I don't see a lot of value in directing through the public name. I think the whole value of this is removing that coupling between the public name and otherwise. One thing that you have done that I don't know if I agree with is that to some extent the public name and the config ID are things that a server can use to choose the configuration that it's going to apply for decrypting the ECH.
Can be, but it's
Like they could
it's
be,
not
right?
supposed to be. It's the ID. That's
The ID is supposed to, but let's face it, the public name is also a selector on this one.
I did ask the
And-
implementers, and they're not using it that way. But yes, please.
Yeah, maybe they could. And the reason I say that is that that suggests that having the server have a say in what the public name is potentially something that you want to consider as part of the design.
So I think there's a distinction here that we have to make clear. The public name itself is chosen by the server exclusively. The public name is what's published in the ECH config. What you're referencing is the outer SNI,
outer SNI, sorry.
which
yes,
is not the
yeah.
public name.
Correct.
Right.
Yeah. So public name, I think, was a misfeature in the first place, but it was the way it got us off the ground. So public name, retiring that concept as a way of doing recovery, I think is a good thing. And this is a better way to do it. It opens up these possibilities in terms of different distribution mechanisms for the updated configs, which is healthy. But I do think it creates that risk.
So there's one question here that we did not decide is the upgrade scenario where some servers have supported this mechanism and clients haven't, or clients have. We are going to be stuck with the public name based authentication because it's what's deployed right now. And if you add this signed extension and make it critical, well, there's no critical extensions in ECH, I don't think. You can't force the upgrade. What I'm saying is the public name based auth is going to be there for a while. Whether or not we move to RPK,
Well,
or
there is we have the
certificates.
possibility of changing the version in the.
Right, it would have to be a breaking version, right?
Right, but you can publish old version and new version things in the DNS if that's what you want us to do.
Okay. Thank you.
Hello, David Adrian, Chrome. I'm really supportive of trying to get rid of outer SNI and all that. However, in terms of like implementing this specific draft, you kind of implied this was to make it easier to deploy, but who are there interested server operators who are like, I want to
Check
deploy
the third name on the
specifically
list.
this. Sorry, where?
Check the third name on the list.
Yes. The people that have already deployed the existing one.
Yes.
Right.
Exactly.
So like in reality, what we have here is a protocol implemented by Chrome and Firefox and deployed by Cloudflare that like Google has been struggling for a while to deploy internally for reasons that are unrelated to outer SNI and this part. Because it turns out that getting keys coordinated between DNS, your front end server, and your software, and then tying all of that into your DNS stack or your TLS stack is like just a complicated process. And so I'd be like a little wary to implement this on the client side. And if the only server implementer that's interested in it is the people that have already deployed it, like I'm not convinced this is going to expand adoption. So I'm curious to what extent this is about removing outer SNI, which seems great, versus like actually expanding adoption, because it's not clear to me that this is going to expand adoption.
I'm not convinced that this will necessarily expand adoption either, but I think it allows any new implementers on the client or server side to kind of remove this hacky update mechanism. And the hacky update mechanism exists for the same reasons that you listed. DNS is very hard to keep in sync with these keys. And having something like this, which is a whole list of future keys that you can use to update the configs, might actually alleviate some of the pressure that you're seeing with stale DNS, for example. So it may be able to help deployment, but I would have to hear from the implementers themselves.
Thank you.
Chris Patton, I am enthusiastic about this idea. Can you go back to the RPK versus PKIX slide? Okay. Okay, server signs. Okay. Okay. Okay, I missed something before about this that I think is I was going to mention. The thing about like sticking signing keys, ECK signing certificates in the web PKI is making sure we don't miss issue is like becomes really, really important. And I guess having a critical, I'm just thinking aloud now, but having a critical extension is good. So the idea is that the signer, okay, so you would have to, the certificate would have to be authoritative for the, okay, I'm good. I think this makes sense.
Yeah.
It would be nice to pick one of these, I guess.
Yeah,
the only other
the
bit.
critical extension is really what closes this off. And we've seen other examples of groups use the web PKI and critical extensions, new ones, web packaging, for example, to sign objects with a TLS cert. And this prevents that from being cross-used in previous protocols, the fact that it's critical.
So I guess like how will discovery work? Like
it's all published the first time you see an ECH config. That gives you all the mechanisms you need to
so, but
update
if I'm just getting like an ECK config from a DNS like record, and it's unauthenticated so far, I don't know if I'm supposed to trust that public name. Like somehow, don't you need to pin the public name, like public names you trust, like on the relying party side?
Dennis maybe can answer this.
That's how ECH works today. You get a public name from DNS. It's not authenticated. And that's what your sort of trust is for the retry config. So this is identical to that. There's no increase or decrease.
So we're still like trust on first use, and we don't.
This is how
know.
ECH works, right?
Okay.
If you're not DNSSEC signed,
okay,
you're trusting
Thanks.
the first one.
Okay, Christian.
Yes, I mean, actually on that specific case, you could do that if you learn the ECH config from the website itself, because your connection to the website is authenticated. You know that you are connecting to that specific website. So when you get it through HTTP, you have a good presumption that it is a valid config. But my point is not that. What happens if the client-facing server and the protected server are not co-located. Because I have this tension in ECH in general, in the ECH architecture, is that the client-facing server must know the private key associated with the configuration. Otherwise, it just cannot unwrap the ECH envelope. But the configuration itself is published by the final server. That final, in that case of HTTP, it is. So I mean, I have this tension there. I mean, how do I resolve that tension? Normally, I mean, I have my server. I want to set, for example, that my server can be served through Cloudflare and Akamai. How do I do that? What is the effect on publishing the configuration? What's the effect on this mechanism?
I don't know that there is an effect. I think this is just taking an object that is currently unauthenticated and adding a signature tag to it. So in every case that it's used, I would imagine you would have more assurances. But maybe I misunderstood the question.
So your signature tag has to be signed by the fronting server, correct?
So, sorry if I can, Christian. Dennis Jackson, Mozilla. So if we lived in this happy world where Akamai had rolled out ECH, and looking at Rich here, then what would, when you sort of want to do that kind of initial DNS advertisement, you're actually in a really tricky spot. And when Cloudflare rolled out ECH, I think there were some issues with this where third-party sites were doing interesting things with DNS and free DNS to sort of load balance between CDNs, and they weren't always aware about, you know, who had which ECH private keys. So I would say this is like largely a bit of an unsolved area. Doing like multi-CDN deployments of ECH is not trivial. Yeah. There was a comment in chat around like sort of how retry works and recoverability around RPK. And I just wanted to sort of highlight that this doesn't change anything about how that works. So today you have an initial config, which is authenticated by a public name. In these drafts, you would have a key signature, sorry, a key hash, and that none of that state persists beyond the initial, when you get the retry configs from the server. So they're as recoverable as each other.
Hi, Eric Pasquilla, more a question than a comment. Have you talked to any CAs about issuing this kind of PK certificate?
No.
Sorry, no?
Not yet,
okay.
no.
That seems like a threshold question pretty early on, right? So as I understand it, Dennis, the way things work with the multi-CDN scenarios, this is why the HTTPS service B records contain the IP address, is right. So you get the right CDN. So, and I read this last night, so like, forgive me if it's like, it was quite late, but as I recall, this in fact does say that you are supposed to only use this with the same IP address as before, right? So you don't get in this weird state where you connected first to Akamai, and where you connect the doc, where Cloudflare advertised, you ECH to Cloudflare, and then you reconnect to Akamai with a new thing. You got to bind it. You got to treat it as if it came out of the same HTTPS record, right?
Right. Yeah. You have one HTTPS record that has the IPs and the key, and this retry mechanism, you would only trust the updates or the listed keys on the IP address that you would originally.
It just crosses out the ECH config and puts in the new one.
Right.
Yeah. That seems like it ought to work fine. I also am a fan of only one thing, and I guess I'm open to being persuaded that it's the PKIX thing, but my current impression is it's the RPK thing.
Yeah, there's mixed opinions on this. They're both practical, I think, in my opinion, but it's about the ecosystem.
Alessandro Ghedini, Cloudflare. Mostly to address David's comment about adoption. As someone who's actually deployed ECH, it's not, universally adopted across all our networks. So while I can't say, we do this and then suddenly everything's great and we can enable ECH 100%, it's on the path of getting to that point, or at least expanding adoption.
So
for us.
can you explain, versus the current deployment versus the deployment with this, why it would be easier to deploy?
Yeah, it's mostly about the disentangling the public name with the retry config. So this is the sort of deployment agility case. And for us, I guess the raw public key would be the method that we would adopt, because the PKX1 kind of has similar problem with the public name. So even if we went to one method, the RPK one would probably be my choice in that case, if that makes sense. Yeah.
Yep.
Great. We have a bonus presentation.
Bonus presentation.
Upload the slides. Let's see if we can do this. Are they there?
Who are we asking for?
Yes, Aijan. Where is he? Come on up. We got time. Okay, so this has been discussed on the list. There's been a couple of messages. This has been discussed on list. He asked if we had time. We didn't think we would. Surprisingly, we got done earlier. I will note, I know you have 10 slides and you got 15 minutes, and please leave 5 minutes for questions.
Okay. So thanks, Chair, to give me the chance. So I want to introduce our new proposal for service affinity based on the TLS. So here is the background for this proposal. We are now in our network, the service.
And you can.
Oh.
Yeah.
So we are now in the network, in our network, the service may be deployed in several locations with the same address. So for example, you can now the service is deployed in three locations with the anycast address, and so when the customer accesses the service, the router will select the different service node to match their requirement. Different customer may be directed to the different service. I think this is okay for the overall traffic, but for one same customer and the unique session of the same customer, all the packets should be routed to the same service node. But if the service is accessed only by the anycast address, when the network status is changed, the packet from the same session of the same customer may be directed to our service node. So we want to avoid such problems. So we call the necessary for the service affinity. So this is our proper one to solve. We also consider the possible solutions currently, for example, load balancer and HTTP and DNS redirection. We have analyzed that they are not suitable for this scenario because for example, HTTP rely only on the application info and cannot utilize the network status info. So there are also drawbacks for the current. I do not introduce there in detail. So our solution for this requirement is we want first the customer when the customer accesses the service, it will use the anycast address. But when the server receives the first packet and recognize that the packet is from the anycast address, we want the server to return to the customer one unicast address, and let the customer establish the TLS session, a new TLS session, and then the following packet will be directed to the unicast address. The connection to the unicast address will be switched to our service node because it is unicast. If we use steal the unicast address, the following packet may be directed to our service. So we utilize the switchover procedure to accomplish the service affinity requirement. This is our main proposal. So here we just also list the procedure. The first, the client send the request to the server using unicast address, and when a router in network receives such a packet, it will direct the packet to the most optimal service node. When the service node, for example, the IP4 service node receives the first packet. When the service node receives this packet, it realizes that the packet is to its unicast address. It will send back the notification information to the customer and told the customer it's unicast address. And the customer then establishes the new TLS session to the unicast address of the servers. So to accomplish we extend the TLS in we define 3 extensions. The first is the notification for from the customer that it supports the migration, and the second is the migration token. It is from the server to notify the customer what is the unique address and what's the session token for the previous connections. And the third is maybe you use the letter by the server to the migration notify. The migration can begin at the immediately or can be initiated from the customer or from the server. So the migration notify is used by the server. Yeah. We also consider some security. The reason that we rely the switchover based on the TLS is the TLS can keep the switchover be secure, and it can let the man in the middle attacker when the switchover take place. So yeah, this is our overall proposal. I think there are some discussion in the list. So if
yeah, so Eric Squirrel, I had a number of comments. I think on the list we had a bit of discussion. I think there are 2 primary comments I have. The first is that I am not yet persuaded TLS is the right layer for this. I don't understand. I think this is a much more appropriate application layer. We don't have to worry about like the race conditions between when the switchover happens and what application message has been delivered and act and which ones have not been, because the application message protocols already have all their own mechanisms for handling connection failures. And now you've introduced a new connection failure that like is weirdly asynchronous to that. So I think I think this is not the right place to do it. To the extent to which it is the right place to do it, this mechanism is not good. So like you don't need all this mechanism because just stuff all the state in the session ticket. You don't need a migration token. You don't need any of that stuff. Take all the state, pick all the session ticket. You don't need any TLS support for that. The only thing you need is the mechanism to say, switch over to this IP address. And I don't know where you think that goes, because again, this is another reason to put it like an HTTP header, because it can't go in an alert because there's no room for it in the alert. But if you put it in application layer, then you can put it in the application layer just fine. So, whereas having like the semantics of NST is just like goofy. So, like I just think this is like architecturally the wrong solution.
I just want to explain, because in this scenario, the selection of the optimal server is taking place at the network
Yeah.
layers. So and
And it tells the application layer what to do. It should bubble up the application layer to instruct it what to do.
Yeah, if we let the work being done in the application layer, we because there are various applications, we must do the extension in each of the application layer. But if we do the switch over in the TLS layer, it can be applied to all the application layer as run on the TLS.
Yeah, but that's bad, not good. And the reason it's bad is because you're creating this basically asynchronous, from the application layer perspective, you're creating a network failure that is asynchronous to the application layer state. It's just like the connection just terminated. And the application, unless you tell the application which packets were delivered and which packets were not, then it is as if the connection just got dropped off in some weird state. Whereas if the application does it, it can arrange to synchronize the state in an appropriate fashion. And by the way, there's like really only one application that matters anyway, which is HTTP.
I think this solution is the application agnostic solutions.
Yeah, but I understand you do, but I guess I'd like you to respond to the point I just made, which is that it creates an asynchronous failure from the application's perspective, where suddenly like some packets were delivered and some packets were not, and the connection just terminated.
I have mentioned in the mail list that Quick is also have some similar procedure. It is also in the transport layers.
No. Quick does have that, but the abstraction Quick does is it pretends that when Quick migrates, the connection state stays up. And so if there were some packets that were sent before the switch and some packets after the switch, they're still delivered as if it were one connection. What this is two connections. And there's no reliability mechanism. There's no way of knowing which packets were handled, which packets were not when the alert was sent and processed.
Okay, thank you.
Yeah, Martin Thompson. This is, I think, superficially like Quick's preferred address mechanism, and that happens during the handshake. But in that mechanism, there's an essential property that this isn't able to provide, and I think that's very challenging in this case, because you're talking about making new TCP connections. So if this were purely HTTP TLS, you would do a redirect, and you would point that at a different host name. You would point that at a host name that resolves to the unicast address, rather than the anycast address, right? So you make a connection, and then you redirect, and you'd have to do a full handshake. That's a little unfortunate, but that's just how it works for that. If there are other applications that need other application protocols that would need this, then they would need similar mechanisms in that. Just to give you an example of why this is particularly challenging, you've got this original connection that's up at the TCP layer that has a bunch of messages that have been exchanged, and at some point there's a message that comes through and says, stop using this one and go and connect to this IP address. But the application that's sitting on top of that is seeing a connection break, as Eka pointed out. And you then have to have this session continuity layer, and we don't have one of those.
So would you like to summarize in list icon? Okay, thank you. Because we also have another commercial from the Pell network. We can discuss more your concerns. Okay, thank you.
That's it. That's it.
Have a nice day. We got done 1 minute and 17 seconds early.